Yes.
Okay. Okay. Hello, everyone, and welcome to Rust London. This is our May event. This is our second remote event. It's great to have you all here. My name is Ernest, and I'm just going to welcome you all. So this is the Rust London Talks. It's our monthly community showcase. We do this every month as part of a range of different community events that the Rust London user group holds for the London community. The purpose of it is to showcase what is going on in London, what different people are doing, different companies are doing with the Rust programming language. The Rust London user group started in June 2014, and as I said, it's run in conjunction with two other community events. We also have the Rust London Code Dojo, which is actually led by one of our speakers today, Luca Palmieri, and we also have the Rust Hack and Learn, which is a sort of Socratic seminar for people more experienced in the language to share some of their experiences and learnings in a casual hangout setting. So over the last year and over the course of time, we've seen a really good positive traction with the programming language in London. There are a ton of companies who are moving from just tinkering with Rust in production to actually baking it in as part of their stack. Here are a few companies based in London who are either experimenting with Rust or going fully fledged and actually using Rust in production. We're actually going to have two companies today, Smarkets and TrueLayer, as well as Matrix as well, who are going to speak about how they're going to be using Rust in production. So we're seeing adoption grow at a very good rate here in London. The Rust London community, at the beginning of this year, we set out our agenda. This was coming off of all of the exciting things that happened in 2019 with async await and with all of the other amazing improvements and steps forward on the roadmap. Now, what we wanted to do and what we will maintain, we will keep doing, is to focus on making our community as welcoming and as open as possible to people of all levels of programming. This COVID situation, the COVID pandemic, has changed all our lives, but it's also given the London community and given us all an opportunity to share and open our reach. So it's very important for us to not just focus on London, but to actually share what we've got with all of the other communities across the world. That brings us on to how we as the Rust London community have our code of conduct. We have signed up to the Berlin Code of Conduct, so the same rules that apply in a physical meetup in the way that we interact with each other apply on a virtual meetup. So the main one being focusing on just being respectful and being just kind to each other in the chat. So we have the live chat, which is open. Please feel free to interact with emojis and memes and any kind of gifts that you want. Respectfully, that'll be a great way to interact because we don't have, you know, the audience interaction that we usually would do. So after every talk, please feel free to let off your fire emojis, let off your clap emojis, and interact with us through the chat that way. But we will still adhere to the Berlin Code of Conduct. The way questions and answers will work for this meetup is we'll have all the talks. So all the speakers will give their talks and you'll be able to ask questions in a panel session at the end of the last speaker. Questions will be taken on Slido. So if you can go to slido.com and if you can enter in this event code, you'll be able to ask your question and it will be read out in the question and answer session at the end of the last speaker. Please, please, please keep in touch and follow us on Twitter. We are at Rust London Users, and the hashtag for the event today is Rust London. So please, please, please follow us on Twitter. That's the best way to interact and to keep in touch with things. Usually at physical meetups, we'll all be going to the pub afterwards to carry on chatting, to carry on talking, to ask more questions to the speakers. We obviously can't do that in this situation, but what we have set up in conjunction with one of the speakers today is the matrix room for Rust. The description for the link for the matrix room is in the description of the YouTube video. So please just jump in there afterwards for a virtual drink after the meetup. It's a way for us to still keep interacting and still keep and to continue building on the community. So today's agenda is we'll have a few announcements just after I finish this opening address. And our first speaker will be Sandro Vicente from Smarkets. We'll then have our keynote talk from Matthew Hodgson from Matrix, and we'll close out with Luca Palmieri from TrueLayer. Then we'll have the question and answer panel session where we can all just ask questions about the talks. Right, so on to a couple of community announcements. I'm going to focus on job postings because that's something that's really important right now. All of the speakers, all of the companies representing themselves today are hiring, and I'll leave this slide up as I'm talking so that you can take pictures of this slide and then follow up with these links and apply to these for these roles at a later date. Also, one of our prominent community members, Red Badger, they're also looking for a lead technical developer as well. So if you're in the market, if you're looking for a change, if you're looking at working in a dev shop that's very Rust friendly, please take a look here and apply away. Thank you. Just a couple of more announcements. Rust Dublin are going to be having their meetup on the 1st of June. So that will be on Monday. So this coming Monday, Rust Dublin are going to be having their remote meetup. So please follow them. They're on Twitter at Rust Dublin. They also have the meetup page as well. So they're going to be doing their remote meetup as well. We also have Rust Tallinn as well, who I think will be hosting a meetup soon. So that's our Estonian Rustations. There's a ton of different events going on, all centered around what's happening with Rust from different communities. But Rust Dublin will be on June the 1st. Also, Oxidize. The call out for speakers Oxidize is now open as well. So if you are into Rust embedded and you want to give a talk at Oxidize, the submissions are open right now. So please go ahead, either go on the website, the Oxidize website, or get in contact with James Munns on Twitter, or actually the Matrix Room, the Rust embedded Matrix Room as well is a great place to go if you want to submit a proposal for a talk. Thank you very much. Now we're going to have our first speaker, Sandro Vicente from Smarkets. So give us a few seconds as we switch over and we start sharing screens. Thank you very much. Clap emojis and fire emojis, please. Clap emojis and fire emojis in the chat. Thank you.
All right, you guys can you hear me? Okay, so what I'm going to, well, first of all, good evening to everyone. My name is Sandro. I'm a software engineer at Smarkets. I work for a team that's in Smarkets, I work for a team that's in charge of the market making. That's pretty much besides the exchange that we provide, we also have like our own market making engine. And what I'm going to do this evening is to run you through a little story of our experience introducing Rust in our tech stack, and how this kind of evolved together with Rust itself, like because the language is improving and developing very quickly. So just to start with, we like at the very beginning, no, not exactly very beginning, but like this is pretty much our the technologies that we had in our main stack, tech stack. Most of our main production code is developed in Python, and at the time that we started introducing Rust, we had to use like eventlets, Flask for the REST API, and Copy and Proto for our intercommunication between components. And then we had the need for development of some new components, remarkably a new order broker service. And since we have been like exploring more performant and modern language, Rust came up as our choice. And when we had our order broker requirement, what we have at the hand was actually September 2018. We had at the time Rust 129, Tokyo Not 1, and we had also some other crates like for the REST API used Gotham and Capin Proto REST. So just to give you a run through what we were trying to do is like pretty much the first service is Order Broker. That was a component that was listening to our trading engines and placing and canceling or receiving the executions from an exchange. And we also had some other auxiliary services like a content service that was mostly to have the data mapping, what was from our side to the exchange side, the events, markets, and so on, and also Reds for persistence. So what was clear on these systems is that they had like a high volume of messages and it was IO bound, like we had to pretty much be doing like dispatching messages between the external elements, the external components, and then asynchronous was pretty much a must on this. And so with Tokyo No 1, we had like the as everyone knows, like all that future interface, and then we needed some way to kind of tame that into some way that was useful for us. So we kind of came up with a model of like having dispatching tasks for components that performed the I/O and received the response from these components, and then we had like a business logic that was orchestrating how these components were interacting with the external, with other external services. So we had like all these components that were interacting, we called interface. And among them, we had like a socket client to talk with the exchange, a trading interface that was it was a socket server, like the pricing engines on our side connected to the broker and so on. And so pretty much each one of these boxes were tasks like performing IO, and then and we had our business logic that was doing the exchange itself. This commands and notification was abstraction that we used, like we wrapped everything that was going from our business logic to the interfaces as a command. and then the response was like sent back to our as a notification. This is our model. So zooming in, like what we had to do is pretty much each interface was running as a coroutine, and our business logic itself was also a coroutine that we call the driver. So how these things were pieced together is that for each driver, we had to create a channel, actually a pair of channels. We called like the command sink and command stream, this notification sink and notification stream. And for these interfaces, it had to like expose like a sink for the command and a stream for the notifications. And then our driver was aggregating all these streams into a single mainstream that the business logic was listening to and processing in a loop whatever came from the stream, and then performed some command, like some, not some command, like some action, and this action became a command that was then set to a main sync dispatcher. So these commands were all like put together and then distributed back to the interfaces. So it was like pretty much a loop of asynchronous messages that you had to write on our own, like it's a homemade one. So was like quite interesting because was a lot. Pretty much we had to have filters that were chained together, and then all this with lots of closures inside them. So this is the main driver part, but it's just like to illustrate how normally the code looked like was pretty much moving closures inside of other closures and so on. And this went into production, and it has been in production for more than 1 year. Like it's pretty much outperforming like our other code in Python by a lot. Like Python is quite slow for this kind of processing comparison to Rust, and we had like sub-milliseconds for processing each message between the components. So that was nice. But then we realized that we can now migrate other parts of our components or other software, other applications that we have, other systems. And then recently we started to migrate our pricing engine as well. Our pricing engine, the pricing service, we started at more or less the end of last year, but then we have been upgrading Rust as we go. And the biggest change in Rust that was the async await had been introduced already, so that was a plus. We had a lot of more tools to work with. And also, since we had to have all that boilerplate to process the commands and the notifications, we decided to put something new. We decided to, we came across the Actix framework that is normally used for web applications, but we realized that the actor model, that's the core of Actix, could serve our purpose quite well and be a good replacement for this boilerplate that we had. So the pricing engine, that is our now new service, as you can see, is very similar. It's pretty much like the broker. That's the service that the first service I told you about is one is the the component which price service send messages to. The pricing service receive like feeds for markets, like pricing feeds, events feeds, if the market is live, if the market is canceled, is suspended, pricing parameters that are set by the traders, and also we have like the supporting services that are doing the mapping between data that is used for to be sent to the broker and from our internal components. So, but the bottom line is that it's really very similar in terms of it has a large volume of messages being processed and is IO bound. So it's still asynchronous. So this is like breaking down how the design became. Like we are using this, as I said, this actor model. So instead of having like this, all this mess of having each creating like our own framework, we are writing to this actor model to create for each component, to encapsulate actually each component to an actor. And the actors, they interact among themselves using messages that are pretty much like a synchronous way. Well, we have here a bit of a mess, like of messages showing up, but zooming into a subset of these components in our service, I left here main. That's pretty much the main actor that creates and destroys everyone. And these actors, the pricing feed, data controller, event feed, strategy, and broker, they are the actors, each one running its own coroutine, communicate among themselves and collaborate to perform the service. So this is a slightly different design, but is again a synchronous design, message based. That's why I think a better abstraction for our service. So in this snapshot, I just showing that like we have a main component here that can be activated by a data controller that then requires subscriptions from the pricing feed and event feed. When they are subscribed, they start to send messages to the strategy. And the strategy then processes these events, sending messages to the broker that will require it to place orders, cancel orders, and the broker send a feedback that the order executed, and then feedbacks to the strategy that then can, again, send new messages or pull orders and so on. All of these into this model of messages and actors. Just to illustrate how the actor is in code-wise is pretty much you have a structure. Here I'm focusing on the strategy. That's one of the core elements. And then we have a structure that then implements a trait of an actor. And this and for this actor, we have to implement traits for each message that it can process. So for this strategy, in fact, can handle like strategy updates, can also handle other messages here, only strategy updates. And the message itself is can be a enum or can be a struct. You just have to be deriving from the message. Also focusing on other components here, this is the event feed. Like you can see that you have this pricing feed and the event feed, they are also handling like the subscribe message. The same subscribe message can be implemented to do an action in the event feed actor and another action in the price feed actor. So this abstraction allows us to detach like the message from the action that happens. How the message is interpreted depends on the actor itself. So also that's fits very nicely to our requirements. And just to show you, like, for example, for our first service that we were still using Tokyo Note 1, we had like always to go through this main driver coroutine that had to be like processing, reading from the stream, and then fit into this stream a handler that then had to return a feature that and everything here had to still be fitting into this feature. Now, if our new model, we kind of can detach a little bit more the things, like we can roughly implement the messages and the actors and the way that the the actors handle these messages. And of course, then it has like supporting functions to wrap into this message handling asynchronous methods. So we could set a lot of asynchronous steps here and then handle the output and chain they together and then handle the errors as well here. Yeah, so from our like journey into like introducing Rust into our stack, we see that like the way that Rust has been evolving improved a lot, like the way that we can make our code more direct, less convoluted, and also the technology that now was enabled by Async Node 2 and like also using a framework helped to smooth the coding in the business logic. So that were very nice things in terms of the process of developing it. One thing that, like, if you are using a new framework, and especially a framework that's based on a model, the actor model, you have to internalize it. You have to really understand, like, how the actor model works, like, to really design your system in terms of, like, actor messages and not, like, hack them. So we need some investment in understanding what is behind it. For the Actics, there has been a lot said about Actics. Most of what is about it is on the web framework, but if you are not working on the website, if you are working on the actor model itself, there is honestly little documentation. So we had to dig a lot into the source code. This is not nice. Like, it could be exploring more like the library to boost like it for not only for web use but also for other applications. But yeah, like, anyways, this is what you can do with what we have, and it's quite good enough, I think, for us. Well, yeah, and this is pretty much like what I had to tell you guys about our story, and thank you very much. Yeah.
Thank you very much, Sandro. Could I please have some clap emojis, some fire emojis, and of course, crab emojis. I want to see all your crab emojis. Please give Sandro some appreciation, a really big hand in the chat. Thank you very much for the talk.
No problem.
Right. We're going to have questions at the end of the last speaker, as I said before. So please keep putting your questions into Slido using the event code, and then all of the questions will be done in a panel format at the end. We're now going to move on to our keynote speaker, someone who I'm very excited to have here at Rust London. Big fan of everything that they're doing, big fan of what they're trying to achieve and bring to the world. We're going to have Matthew Hodgson from matrix.org.
Thanks very much, Ernest. Am I coming through okay?
Yes, you should be fine. Fire emojis, clap emojis, loads of crab emojis for Matthew, please. Thank you.
Thank you very much. Okay, I'm going to just share my screen, hopefully. Oh, let me get rid of there. Can you see that okay? Am I coming through with the screen share? Yes? No? I see some cautious nodding.
Yes.
Yeah, we can see slides. Yeah.
Perfect, brilliant. Okay, so hi everybody. I'm Matthew Hodgson, and I'm the project tech lead for matrix.org, and wanted to talk to you today about how we're using Rust in the Matrix ecosystem, and how the wider community is using Rust in Matrix. I should apologize that I'm personally not a Rust developer that much yet, although I occasionally kind of poke at things to fix builds and debug things, but I haven't written very much myself. So I'm here more with my project lead hat on for Matrix as a whole. So Matrix is an open network for secure, decentralized real-time communication. We see it very much as a mission to create the open communication layer for the web, because the web is great in many ways. You can publish information, you can build web apps, but there's never been an interoperable way to do real-time chat or VoIP or some kind of AR, VR fabric, or indeed exchange IoT data. So what we did about 6 years ago was to write a spec of some simple HTTP APIs that define how you can publish arbitrary JSON blobs to Matrix, and anybody anywhere else on the network can consume them, and they would be persisted with eventual consistency replicated over the servers in the network, and you would get end-to-end encryption in there too, so that you basically have an end-to-end encrypted communication plane for the web. So practically speaking, we're trying to build a global decentralized encrypted comms network. What it looks like is this. If you've got a whole bunch of islands like, I don't know, IRC networks or XMPP or Slack or Discord, Telegram, Github, and I think we've got bridges to about 60 different services now, Matrix can be seen to sit in the middle as this network of servers who are going and replicating conversations between each other. And you have the green guys who are native Matrix users going and talking to other native Matrix users, or they could be bridged through to Slack or IRC and talking to people on remote networks too. The main technical novelty is that we replicate these conversations so that if this guy on this server is talking in a conversation with this guy on this server, then the servers literally build up a replicated data structure that is shared between the two, very, very similar to Git. And you can kind of think of Matrix as being equivalent to Git in terms of taking an existing technology, in this instance, instant messaging and chat, and decentralizing it, much like it came along and decentralized version control from the likes of Subversion and CVS. So the thesis is that no single party should ever own your conversations. They should be replicated and shared over all of the participants. And this is kind of subversive because it means that you can never have a single point of control or censorship or commercial advantage over conversations. It's kind of data privacy and data self-sovereignty first. It means that everybody is in full control of their own comms infrastructure rather than being beholden to the nice people at Slack or Teams or Skype or whoever it might happen to be. Architecturally, you have your servers, the clients connect to the servers, and you have application services, which are basically clients on steroids, which provide functionality like bridges or bots or integrations that need to be able to act on behalf of the whole server. Very similar to how IRC services work, if you're familiar with IRC. And then finally, we have identity servers, which map through existing IDs like phone numbers or email addresses, strictly optionally through to matrix IDs. In terms of what the spec does, you get conversation history, of course, and conversation history is the first-class citizen. Lots of people say, oh, this is just reinventing IRC, or it's reinventing XMPP, and that's just missing the point entirely, in that both XMPP and IRC are basically message passing systems. Conversation history is tacked on as an afterthought, whereas Matrix is the other way around. You can't pass messages in Matrix. All you can do is replicate conversation history between different servers. So it's just a fundamentally different architecture of how you express human conversation. If people remember newsgroups and Usenet, Matrix is an awful lot more like NNTP and Usenet than, say, SMTP or email, which is obviously message passing. Everything is group message based. One-to-one conversations are actually a group of 2 people. So you just don't make any distinction between direct messages, under the hood, and chat rooms. End-to-end encryption is something that we've spent a huge amount of time on, and we eventually turned it on by default a few weeks ago now, after 3 years of effort going and taking the work that Signal did, going and specifying the double ratchet algorithm, which is what Signal uses to create the key sequence for encrypting your conversations. And we decentralized it and spread it out over the whole network, and also extended it to work with large group conversations with more than 200 people. It can go up to thousands of devices, so that you can have full end-to-end encrypted private group conversations. We get VoIP. We specify VoIP signaling, push notification rules on the server-side push, read receipts, typing notifications presence, all of the kind of table stakes of what you would expect to get from Slack or WhatsApp or Discord, except done in an open source, open standardized way. You even get a content repository. You can also store arbitrary data for given users per account, and also in the context of a room. So the way to think of Matrix architecturally is this, and the main thing is the spec. And this is a huge wodge of OpenAPI, used to be Swagger, but now OpenAPI documentation detailing how these APIs work for doing all of these functions. And also the Markdown and the Rust restructured text, as opposed to Rust, the language, which goes and glues it all together into one great big spec document that you can see at matrix.org/docs/spec. And this is looked after by the matrix.org Foundation. And in fact, all of the green stuff on this slide is built by the matrix.org Foundation as a non-profit UK company that we set up in order to look after the spec and the protocol for the benefit of everybody building on top of it. Talking of building on top of it, we ship as the foundation 2 server implementations today, one in Python in Twisted called Synapse, and also a Go one, please don't shoot us, called Dendrite, which is a microservices-based approach. We then also have lots of services and bridges built on top, IRC bridges, Slack bridges, Github, XMPP, and a few others which we build ourselves. And then the purple side here are ones that the community are working on. And some of the most notable community projects, particularly right now, is a Rust server implementation called Conduit. There's also a Scalar server called Masquerine, used to be called Plasma. And there is a huge galaxy of bridges and bots and integrations that people have written from the community. Meanwhile, on the client side, we provide at least 4 official SDKs. In fact, we're missing the Python one here, but the officially supported SDKs we do are JavaScript, iOS, Android in Java, Android in Kotlin, and also Python done as Matrix NIO. And on top of that, we provide component UIs for building chat apps, and then chat app reference clients. We used to have one called Console that was kind of the starting point. And more recently, we have Riot, which is really the flagship Matrix app that is pushed out by New Vector, which is the for-profit startup that we set up a few years ago in order to try to keep the lights on and hire the core Matrix team to keep working on Matrix full-time. So Riot, if you're not familiar with it, looks and smells a bit like Slack or WhatsApp and has all the features you would expect and really is a showcase for everything that Matrix can do. Meanwhile, on the purple side, lots and lots of other clients out there. There's Fractal from the GNOME project, written in GTK and Rust. There are command line clients like WeChat matrix-rs, again written in Rust. There's Neko, which is written in C++ and QML and Qt. There's Quaternion, also Qt and C++, but no QML. GoMux, which is written weirdly enough in Go, but is a command line text user interface. Seaglass, which is a native Mac OS Cocoa app. You've even got Mozilla Thunderbird with native Matrix support in it these days, although it's hidden behind the config flag right now. So that's kind of a map of literally what Matrix is. And we're very excited to mention that we do have now an additional official SDK, which is approaching release. It's, I guess, in beta right now, called, weirdly enough, matrix-rust-sdk. And we'll talk a bunch about that in a few minutes. In terms of community uptake for Matrix, a good metric is to look at the number of Matrix IDs there are on the network. This is based on the phone home stats, which Matrix servers optionally participate in when you set them going. And we go and take the anonymous aggregated stats. And as of this morning, when I generated this, we had 17.8 million unique IDs visible somewhere on the network. And you can see how that's been growing over the years. And other stats, we've got about 7 million messages a day on the network visible, about 5.5 million chat rooms. We can see 45,000 servers. So this is really getting quite chunky. This is bigger than Bitcoin in terms of federated nodes now. The minor issue being that it's not quite as big as email or the web, but it's heading in the right direction. The matrix.org home server was the first one we ever set going, and it's still one of the bigger ones. And we see about 35 messages a second coming in and about 3,500 going out, because the average size of room is about 100 users when you smear it out over massive rooms with hundreds of thousands of users versus ones with a handful of users. Looking at GitHub, there's at least 500 projects building using the protocol, and we're aware of at least 100 companies who are building products on top of it. And weirdly, and most interestingly, Matrix has a big fan base with governments, because it turns out that governments really like decentralized end-to-end encrypted chat when it's for themselves. And so the French government adopted Matrix as the official communication platform across the entire public sector a few years ago, and more are now joining them as well. So that's basically where Matrix is from a high level. Hopefully that was interesting and gives some context as to what we're doing with Rust in the community today. So I went and picked out a bunch of projects which are particularly interesting in Rust to dig into. Not going to talk about all of them in detail, but from a quick whistle-stop tour, we've got 3 from the Matrix core team. The most important one is probably Seshat. And Seshat is a search engine for end-to-end encrypted content. Because you might remember earlier, I mentioned that we have server-side search in Matrix, but this is useless if your content is end-to-end encrypted, because the server can't index it. So instead, we have Seshat as a client-side indexing system built on top of the Tantavi full-text search engine in Rust. And we wrote it in Rust, so it could be completely cross-platform and very efficient native code across all of the Matrix clients, which might want to go and have a client-side full-text search indexing for their end-to-end encrypted chat. So far, it only ships in Riot Desktop, which is our Electron-based version of Riot on desktop, but we added it as a native module into the Electron code. I don't believe it compiles to WASM currently due to the threading limitations in WASM. So you have to do it as proper native code running on Windows and Linux and Mac OS in the Electron app. But it works beautifully well. I'll demo it in a minute. And then we have the Rust SDK, which I mentioned earlier, which is really a first-class, best-of-breed, latest generation client SDK built on Rust. And then more randomly, we've done a lot of random utilities in Rust. For instance, Synapse is our Python Matrix home server implementation, but a lot of the Synapse team really like Rust, and frankly, they wish that we'd written it in Rust. And when we started it 6 years ago, if Rust had been a little bit more mature, we probably would have. So instead, they've kind of made up for it by doing lots of add-on processes in Rust alongside it. So this particular guy goes and helps compress your database very efficiently by applying a compression algorithm to how we store matrix state. Otherwise, it can get very big in the naive implementation that Synapse does. And also, when we proof out new algorithms in Matrix, particularly around the merge resolution algorithm that is used for resolving decentralized state, we use Rust as well for proofing that sort of thing out. On the community side, though, there's a lot more stuff happening. Probably most famously, there's Rumor, which was one of the very first community projects for Rust. It stands for Rust Matrix. And the intention was to be an entire stack of both client and server and libraries. In the end, it just became client libraries, but these have been super useful in terms of being built and used by other projects. So for instance, the official matrix-rust SDK uses the data model from Rumor. And then you have Fractal, which we mentioned earlier as an official GNOME GTK Rust matrix client. Conduit, the server. WeChat, matrix-rs, is where the matrix-rust SDK is basically being tested using the WeChat command line or text user interface chat system in Rust to test out the new Rust SDK. And then, excitingly, we have an entirely new client called Daydream that was started 2 days ago, I think, or yesterday. And I came across it 2 hours ago when I was trying to get WeChat to compile on my Mac and having some problems with the CC crate. And they said, hey, why don't you just demo Daydream? So I'm going to show you Daydream. And it will be, I think, the first time in the world anybody has seen this project. And then finally, Rust Matrix Data is one of the other projects I mentioned for helping model how Matrix works in Rust. So let's jump in a little bit more detail. I already mentioned Seshat. So this is the stack here on Seshat. You've got Tantavi at the bottom. It goes and stores your data in SQLite, encrypting it by SQL Cipher. We wrap it for use in Electron in a node wrapper, which is then a JavaScript library called matrix-rust that could be linked by our Matrix React SDK into the Electron Riot app. And if I just get out of the presentation briefly, I'm hoping you can still see my screen. And here is Riot running in Electron. This is Riot Nightly because we do CI builds every day. And I'm hoping this is coming up okay. Yep, it is. Cool. Let me shrink down Ernest to the corner of the screen somewhere. And this room here isn't encrypted at all. So if I go and search it for a word like Daydream, it's actually going to go to the server and it would do a Postgres full text search to find the results for the word Daydream. But if I find another room, which is hopefully not going to be too sensitive, let me think of a good test room to look in. I'll go and look in our Megalm test room. So this is where we do a lot of our stress testing of our end-to-end encryption. It's a room with thousands of users in it and all sorts of history as people try to break it. And if I go and search in here for a word like synapse, say, this is now going through to Seshat under the hood, precisely the same UI, totally different code paths, going and talking to SQLite, and here we go. There are a couple of instances, despite the room being end-to-end encrypted, where you can get people complaining about Synapse. So if I can click through on one of those messages, it will pull it up, hopefully. Nothing quite like an unrehearsed live demo. Let's try to pull up the history of that random old message from the depths of time. Well, you might just have to trust me that if we go back down to the bottom and look at one of these messages, it is, and we look at the raw source, you can see the ciphertext in there. So there's no way that the server would have been indexing that. But Tantavi and Seshat saves the day. The really fun thing that we can do with this is to then gossip the indexes, which are sitting there as the SQL Cipher encrypted databases between clients. So for instance, I could leave my Riot desktop going as a Matrix client indexing all of these rooms client side. But then if I install Riot or another Matrix client on my phone, it can just copy over a couple of megs of encrypted Tantavi indexes, and then I have full search on my phone without the phone having to go and re-index everything itself. So it's been a huge success so far, lots and lots of fun, and looked forward to seeing what happens with Seshat going forwards. What other things do we have in Rust? Then we've got the actual matrix-rust SDK itself. As I said, entirely new official SDK, targeting particularly desktop clients and daemons, but possibly other things too. And it's in some ways a third generation of the same SDK that we had two Python ones. And then after the second one, the guy who wrote matrix-rust-sdk, our current Python one, said, hey, I'm going to do it again in Rust. And it's taking a lot of the learnings from the Python one, particularly the NIO pattern, which means no IO, in terms of isolating it from any of the network behavior for IO. So it's a kind of platonic ideal of how the SDK can work, and then you plug into it whatever network interface you want and whatever transport you want. Excitingly, it has full end-to-end encryption support, and it uses request and SERDI, JSON and rumor. And as I mentioned, it's being used in WeChat. And the fun thing is that Daydream, as of a few hours ago, has gone and taken this thing, compiled it to WASM in browser, and they've gone and built this, a guy called MTR Nord, who's one of our longest-term community matrix hackers, has gone and built this new client called Daydream as a very experimental proof-of-concept client, showing this running in browser. So here it is. Hopefully you can see it. And I'm just going to log into my personal server on Arisphere I think I'm called Matthew Test. And here I am logged in. Very, very, very simple UI here. If I go into a room called Rust Test, you can see there are some messages in it. And really excitingly, if we look in the network inspector, hopefully this is coming through on the stream, you can see that there is a whole bunch of Rust debugging going on. So literally source/app.rs is going and logging the matrix messages saying, hello world, hello, hello boot, and all that sort of thing. And if I go and open up Riot alongside it, where is it? So here is Riot looking at the same room, and go and bring the right window up here, and I can see something back like, hello Daydream. There you go. Pretty fast, actually. Super fast. Yay. And so it's scrolling off the bottom. But you get the idea. Shame it doesn't send messages yet. So it's really cool to see the matrix-rust-sdk in the world running in browser via WASM. World first. Congratulations, MTR Nord, for getting it to work, and thank you for letting me demo it before you showed it to anybody else. What else can I show you here? I think there's just a few more slides. There's Fractal, looking really pretty. This would be a really fun project for somebody to hack on, because they've done some great UI work on the GTK layer. The matrix layer could be a lot more sophisticated, and it was kind of, it's probably 3 years old now. 3 years old now, and what would be really nice would be to just swap it out for matrix-rust-sdk, because then you get all of the end-to-end encryption and all of the best practice stuff that we've just defined in the official SDK. So if you like GTK and you like native desktop apps, please go and hang out with the Fractal guys. They're also a really nice team to hack with. Then there's Conduit, another great team to hack with. It's only a couple of months old, or less than that possibly, but it's incredibly performant and usable matrix server. Interestingly, it's using SLED exclusively for persistence at the moment, but it's unrecognizably fast. They're focused a lot on just making the client-server API work well. So you've got things like end-to-end encryption support, media repository, room lists, invites, all of these things are working well. The big thing that is yet to happen is actual federation with a wider matrix network. This stuff is hard, but the good news is that we've been solving it in Dendrite, which is the Go implementation, and it's looking pretty good. If you're interested in this, there's a Riot, which is plugged up onto a sample server running at riot.conduit.rs, and go and sign up for an account on it and see how fast it is. And if you like hacking on Rust and you're interested in Matrix, I thoroughly recommend hanging out in the community there. It's one of these really fun open source projects where there's a really sharp project lead who's doing loads and loads of stuff, and then whenever somebody else turns up to offer to help, he says, yeah, go and do this massive feature and have fun, and then he merges it. So projects are building really fast, really fun. Recommend. Finally, Rust, what are we going to do in the future? Back in the day, we thought, hey, this is what we have today. Clients talking to servers, talking to servers. What would happen if we had a local daemon where you could offload the hard stuff like search and encryption? And we built this thing called Pantalaimon, which is written in Python. And in fact, if that is now being rewritten in Rust using the matrix-rust-sdk. And you could even go so far as embed that into your client, at which point you basically have a cross-platform Rust SDK platform. But in future, you could even go fully peer-to-peer and put the entire server into the client, at which point you have a totally decentralized peer-to-peer dialect of Matrix. So going very quickly, Pantalaimon mentioned it's this daemon for offloading your end-to-end encryption. Works very, very well, except it's in Python, but it's literally being rewritten as we speak in Matrix Rust. Architecturally, you'd normally go browser to server to browser. But in a P2P world, using a daemon, you can instead run a local home server. Currently, Dendrite is what we've been playing with in Go. But even beyond that, you can compile Go down to WebAssembly and then have full peer-to-peer in-browser running a service worker with your entire matrix server locally that uses then a peer-to-peer transport like libp2p or Yggdrasil or DAT, Hyperswarm, I should say, as a way to replicate data peer-to-peer. And we're hoping that it won't just be Dendrite running in service workers. In practice, Dendrite is 25 megabytes of WASM. I'm sure that if it was written in Rust, it would be 10 times smaller than that. And so we're looking forward to people building Conduit and other Rust servers and running them client-side for peer-to-peer Matrix going forwards. So the path forwards there is that you can actually use peer-to-peer matrix today. Go to p2p.riot.im and you'll find yourself with 25 megabytes of Go WASM running in a service worker, participating in the peer-to-peer network. But we need to evaluate other networks as well as libp2p. We need to do account portability, low bandwidth transports, and better implementations, and potentially Rust implementations too. Finally, for Matrix, we've got first-time user experience coming up next, because our UX is still not as good as Slack, but it has to be if the project succeeds. Riot X is our rewrite on Android, coming up to 1.0 at the end of June, and there's a whole bunch of other work on the horizon as well. I'm painfully aware that I've probably run over my time slot, so I should shut up now. Thank you very much for listening. I hope it was useful.
Thank you very much, Matthew, and no worries about it at all. You really epitomize in terms of what Matrix does and the community that you have. You really epitomize everything about open source, boundless opportunities and potential with what you got going on. So again, congratulations on everything. Thank you for the exclusive demo, a world first here at Rust London. And yeah, loads of clap emojis, crab emojis, fire emojis, the whole lot. Thank you very much, Matthew.
Thank you.
Now, I just want to give us some breaking news. So we've just had some breaking news in. Literally for the 5th year in a row, Rust is the most loved programming language on Stack Overflow. So congratulations to everyone. Congratulations to everyone in the community worldwide for continuing to just do cool stuff, you know. Congratulations to the core team who continue to build out the features that we're all looking for. So loads of crab emojis, loads of fire emojis, please. 5 years in a row, most loved programming language on Stack Overflow. Congratulations. Right. Now, again, we're going to have questions at the end of our final speaker who's coming up now. So please jump into the Slido, use the event code, and ask your questions there. And then we'll have our panel session at the end. Thank you very much. Now, coming up, we have our final speaker. You all know him really well. He is the lead of the Rust London Code Dojo. He's lead developer at TrueLayer. He gave an amazing talk in January. He's now giving us an amazing follow-up on all the stuff that's been happening at TrueLayer with Rust in production. Luca Palmieri. Clap emojis, fire emojis, crab emojis, please.
Hello, everybody. So I don't have a cool setup like Matthew, so I'm going to give you a few seconds of my beautiful face, shaved after COVID, and then I'll switch to slides. Let me see. A bunch of permissions. Nice. Cool. Are the slides visible? Well, I can't see nothing, so I assume they are. Beautiful. What are we talking about tonight? We're talking about telemetry for APIs. So as Hannes was saying, we chatted about using Rust for enterprise development back in January. And then at TrueLayer, we went on and actually deployed an API using Rust, and we'll chat more about that. And we spend a lot of time on the non-functional requirements. So to get logs, metrics, tracing, and so on and so forth. And we'll see how that went out with the current Crate ecosystem. For those of you who don't know me, which is probably a lot of people in London, plus all the people not in London, my name is Luca Palmieri. I'm the lead engineer at TrueLayer, which I've been for a year and a half at this point. I'm one of the co-organizer on the Rust London meetup, and in particular, curate the Rust Code Dojo. I am the author of a bunch of crates in the Rust ecosystem, some stuff in the numerical machine learning side, so in the restarts, Lympha, and I've been recently working a little bit more on the web stuff. So Wiremark for HTTP testing, tracing Boolean formatter for tracing, and we'll chat more about that later. And I'm also writing a book on Rust API development called Zero to Production. So if you're interested, that's the link to the website, and it's going to be published chapter by chapter. Now, what we're talking about? We're talking about Donate Direct. So Donate Direct is a project that we did kind of off the charts at TrueLayer as a hackathon project. We offer financial services. In particular, we offer payment initiation. So we allow you to create flows where you can pay from your bank account. In the old COVID situation, we decided to create an application that allowed you to donate money to charities using our payments initiation technology without taking any fee. No fixed fee, no percentage fee, nothing at all. You just go in there, there's a list of charities who are supporting different aspects of the impacted community, and you can donate directly from your bank account. You can see in this amazing GIF prepared by somebody much more skilled than myself, how more or less the whole flow looks like. And the URL is in the top right corner. Now, the NetDirect is composed of two pieces. So on one side, you have the front end, which is a React application, single page application. Under the hood, you have a backend API, which runs on a server, which is written in Rust. And truth be told, this is indeed the first Rust API running in production through Layer. So I can't see the chat. I will appreciate all the emojis afterwards. It's been a long time coming. We've been playing with Rust for a very long time in build tooling, CLI, scripts, all sorts of things. Some APIs which power some of our sandboxes, but not really for production user, customer-facing, mission-critical. And we did this as a way to understand how to use Rust in production, because there's a lot of things that go into fulfilling functional requirements, so making sure the application does what it needs to do. But there's actually a lot more stuff that goes into making sure the application is observable. I can understand what the application is doing, and in particular, I can understand what the application is not doing when things go wrong. And as Boromir reminds us, one does not simply walk into production. There's a lot of things that you need to do to make sure that we can actually support that kind of software. And if you're introducing a new stack, so if you're introducing Rust into a stack which currently supports .NET Core, Python, and Node, then you need to do the bootstrapping. Just to give you a little bit of coordinates, what does our production environment look like? So at TrueLayer, we run a microservice architecture, which is composed of deployments on Kubernetes. So Kubernetes orchestrates all these different workloads. Each API is a deployment. A deployment is basically conceptually a service, and it orchestrates a bunch of pods. Each of these pods is the logical unit of work, and it might contain one or more containers. And so we might have a deployment which serves our donate API. This API generally runs 3 pods for redundancy. And each of those pods might contain the Rust application in a container, for example, Nginx in another container to do some termination and other reverse proxy thingies. The way we do this is, of course, gives us some nice things, gives us scalability, gives us decoupling, especially in the organization side, but of course introduces complexity. I think this plot made quite a round on the internet. It's from Munz's microservice architecture, not TrueLayers, and it shows just how complex it can be when you start having a lot of microservices chatting over the network, and how interactions can quickly become troublesome. Which, oh, there's a spot on the GIF, didn't want to press, which makes it even more complicated when you need to troubleshoot when stuff fails. Because in like a monolith world, you would go into your monolith, you would have your logs, and you would basically understand what was happening. In your distributed system world, your checkout system is failing, but actually it's not the checkout system that is failing. The checkout system is failing because, I don't know, the user system is failing because a database of the client system is failing. But you only find out about what is actually going down 3 hops down the dependency chain. Or sometimes actually nothing is clearly the root cause, but everything is not working. So it's really crucial to be able to understand what is going wrong, especially be able to answer questions that you don't know in advance, the so-called unknown unknowns. So, as we said, you do not just work in production. And to stay in the Lord of the Rings world, we have the famous or infamous, depending who you ask and at what point of that layer career, pre-production checklist. The pre-production checklist is a list of best practices that we want all services that are going into the production cluster to follow. And they range widely on different aspects, but they mostly follow non-functional requirements. And it's that like tension between going fast and like, yeah, act together this API with ActiveWeb, boom, ship it, push it in prod, and be reliable. Like, we're a financial technology company, we operate payment initiation, we handle sensitive data, we really have to do it properly. So you generally want metrics, tracing logs, horizontal pod autoscaler to kind of handle traffic bursts, alerts to get people paged if stuff is going down, network policy to make sure not everybody's talking to everybody, liveness probes to detect when applications are going unresponsive, and so on and so forth. And each one of those little elements in that checklist takes time. And of course, things that take time sometimes are a little bit annoying because you're really excited, you want to get this thing launched. So what do you do? Just a little bit of details on the telemetry setup. So that's what we're going to focus tonight. So of all those requirements, we're just going to look at telemetry. We're focusing on three things. That's logs, which we ship from the application. They're pushed into Elasticsearch via Kinesis data stream. That's metrics, which are created by Prometheus on an interval. I think 15 seconds is our setup at the moment. Then there's traces, distributed tracing in particular, that we push into Jaeger. If you're not familiar with some of this telemetry data, I'll give more details as we go through one by one. Now, the key lesson and my core belief when it comes to development and software development in general is that in the long run, convenience beats correctness. So people will strive to do the right thing, but eventually they do the convenient thing. So you want them to land in what is called the pit of success. You want to land in a system where doing the right thing is convenient. That's the right design. That's the design you want to strive for. Now, we have .NET Core as our main stack for building backend applications. How did we build this pit of success? Well, we built libraries, as you generally do. So we built a pool of shared code, which makes it very, very easy to add all those bits to your application. Pull in a NuGet package, add a bunch of lines in the startup, boom, you have everything. So the question is, how difficult would it be to bootstrap telemetry Rust to make it as easy to get the same level of observability, or ideally more observability, because, of course, you always want to raise the bar. So let's go one type of metric, one type of telemetry data, and we'll see how each of those actually compares. Let's start with metrics. Metrics are mostly useful to understand how your service is doing right now in the aggregated. You ask questions such as, what's my error rate? What percentage of API requests is currently failing with a 400 or 4xx code? How many replicas of this application do we have? What's the 99 percentile latency on this specific action? And they're generally used for monitoring in real time, and secondly, for alerting. We use metrics to alert, especially during the night, if our system is down or experiencing degradation. And we want alerts, of course, to be as real time as possible because we want to minimize the downtime or the degradation time for our customers, and as much as possible fulfill those SLAs. That's what metrics look like. It's like a time series format. I think is inherited from statsd, and it's kind of remained the same throughout. And this is mostly scaled by Prometheus. So this is the response that your application is supposed to return when you call an endpoint, which is generally called /metrics. And we'll output all of this stuff at once. And then time series database will make sense of it and allow you to query it. For example, Grafana. It makes some very beautiful color plots, which I'm not going to show you tonight. Easy, easy, easy. So the Nate API, as I've said, is a backend REST API. It's built on ActiveWeb. There's a crate called ActiveWeb Prom, ActiveWeb Prometheus. You don't pay by characters, crate order, but the crate is really, really good. You just have a middleware, you set some stuff, so the name of your application, in this case API, what endpoint you want to use to expose the metrics. You can do some customization if you want. Add it to your app, launch, done. That's pretty much as easy as it gets. Oh, yeah, there was a GIF. I was wondering why the page was blank. So metrics, really, really easy, not much to say. Logging. Logging is an interesting one. So the Rust ecosystem has more or less standardized on the log crate. The log crate uses the facade pattern. So log crate doesn't implement any functionality to actually, I don't know, print logs to standard out. ship logs to a remote sync or anything else. Log crate just tells you, this is the user API that I want user to use to emit logs. And then users need to plug in their own implementation. And there's a bunch with different APIs and different functionalities, and everybody has like his favorites, and they're more or less complex depending on what you need to do. So, and your entry point, the application, generate your main function in a binary. You would initiate your actual implementation, and that from that point onward, all the logs would actually go into that log implementation, which will do whatever it needs to do. In this case, the env longer will print them to standard out. And they will look more or less like this. Now, logging is all nice and cool, but when you're running an actual system, it's not enough. Like, you don't want to go and do string parsing on some log lines. You want to go and do queries in an actual query system, like Elasticsearch or TimeTV, which was mentioned before by Matthew. To do that, you want structured logging. So you want your logs to be structured roughly as a JSON object. Key and values, potentially nested, and you can do queries around it, and potentially also index it. Now, structured logging was only recently added to the log crate, and it's currently behind the feature gate, the KV feature gate, which is marked as unstable, which is extremely cool. It's a very positive development. The bummer is none of the mainstream loggers is actually implemented the key value feature, so you don't get structured logging, which is a little bit sad, but hopefully that will get better with time. Why do we care so much about structured logging? We also care about structured logging because we want context. We want context attached to each of our logs, and we want to be able to answer questions such as, show me all the requests that return a 500 for this client ID. And we want the answer to come very fast, and we don't want it to be too clumsy to actually do the searches. Because there's loads of people who want this information. It's not just developers who know how to like kind of grep through their logs. It's also operators, so support people, PMs, business people. It needs to be easy to get the information you want. So if you want structured logging and you can't use the log crate, as we just discussed, the default answer in the Rust community was to use slog structured logging. Historically, the only one that supports it. It's extremely configurable, and it provides supports for a lot of different things. You can ship log standard out, you can ship log using a background thread, you can ship log to a file, you can rotate files, like you can do all sorts of things, and you can customize the formatting and so on and so forth. So really, really nice. On the other side, it can be really painful to work with logs in terms of ergonomics. That's not necessarily a fault of logs, as we will see, but it's just the way it is. Let's look at this function. Let's call it yakshave. So this comes straight from the documentation of the log crate, and then it's picked up in other crates documentations to show how they work. Let's suppose the yakshave is doing something interesting. Let's suppose yakshave is actually, I don't know, calling an API to fetch information. In the example of TrueLayer, yakshave might be calling a bank API to fetch transactions. Now, if I want to know from my logs how the stuff is going, generally I want to track, as we said, context. So, for example, user ID in this case. And I want it to be associated to each log line that describes this operation. I want to capture when the operation started. I want to capture how long it took. And I want to capture some additional stuff. And the log crate works with events. So you see a log line every time you want to do that. And that leads to a lot of noisy code. And then there's also the problem of how we pass this context down. Do we pass the logger down? Do we pass the user ID? And then we recreate that downstreams. It's a little bit complicated. The type of data structure or concept that we actually want to work with is the span. Span is the primary building block of a trace, which is redundant if you don't know what a trace is, but let's say is the unit of work done by our system. It's something that logically makes sense and we do as a unit. Call this API, save this data, compute this price, whatever. What the system does, that's a span. Spans are created. You enter a span, you do some stuff inside the span, and then you end the span. And we can see the span here, right? So the first log line is when the span begins. The second log line is just some event happening in the span. A little bit weird yet. We pass that down, and then the span ends with that yakshave end. And of course, as we said, each span needs to be able to be rich with metadata. So the user ID everywhere. Each event should have all the context of the span, and so on and so forth. And then spans need to be able to be in relationship with one another. So I want to be able to create a span for that subunit to work. And I want that span to be a child of the span in Yakshape and inherit all the properties so that I get the full lineage of what's happening. And now, yes, this looks like a span done with the log crate. But yeah, you really need to squint to understand that that's a span. And the most important problem is that all this context, all this data structure, all this reasoning is in your mind. That's a lot of cognitive overhead, and that's something that you need to explain every time somebody else jumps on the code base. Well, actually, you want to treat that as first-class object, first-class concept, and you don't really want to be having that as a programming pattern. You want your programming patterns to become types. That's how you actually make this maintainable over time. And that's where it enters the scene, the tracing crate. Tracing crate describes itself as a scoped structure logging and diagnostics system. And we're going to look at exactly the same example done with the tracing crate. So span and events are first-class objects. So we create a span at the beginning of the function, which has a level, as a log line. So it's a span at debug level, as a name, and we associate the user ID. And then we enter the span. Here we're using the guard pattern. So the span begins, like the span is entered when you do span enter, and then the span ends, well, you exit it, and then you also end the span when the enter guard is dropped. And given that it goes out of scope at the end of the function, it's dropped at the end of the function. And you can attach metadata, as we said. So we can attach the user property at the beginning, and that metadata is going to be associated to anything that happens to that span going forward. Events can either be attached to the span. So if they happen inside the span, they are automatically attached to it, or they can be orphaned if they happen outside of a span. And if you really want to push it, and you don't even want to see the small boilerplate of span creation and entering a span, there's a macro. As with most things in Rust, there's a proc macro. This proc macro just automatically generates that code for you, and then you can simply log events inside of your unit of work. And you also have a bunch of configuration if you want to capture it captures all the arguments by default. You can choose not to capture them. You can add additional arguments. You can use not to use the name of the function, and so on and so forth. Documentation of the tracing crate is embarrassingly good. It's extremely well done. And I mean, it's one of the best I've seen in the Rust community. So you go there, you find all the info you need. Tracing follows the same principle of log. So it's not like the tracing crate is this mega monolith, ships interface, implementation, or possible syncs. Tracing crate defines the interface, and particularly the tracing subscriber defines the subscriber trait, which is very convenient to implement your own syncs. And then you can choose which syncs and layers and subscribers you want to use, and you mount them at the beginning of your application. So in this case, we are using the Boolean formatting layer, which I wrote for the Donate API, which takes the span data and then formats it to standard out using Boolean format. And we're just mounting it and then setting it as the global default. And unit of work will automatically pick it up. So as we said, we have subscribers. You can combine them using a layer model. You can log the standard out or remote HTTP files, whatever you need. You can use the same spans and events that you're using for structured logging and ship them to a distributed tracing system and get distributed tracing. And so what we're going to be chatting in a second. And potentially with OpenTelemetry, you will also be able to compute metrics. So not even need that middleware that we saw before. All of this just by configuring the tracing crate at the beginning, which is insane, insanely convenient, insanely powerful. So extremely pleased. You can see the output of a similar example, a screenshotted here using tracing Boolean formatter. I think the GIF truly expresses how pleased I was with the outcome. So redirect. Redirect was instrumented with the tracing crate. Best choice in life. We wrote tracing Boolean formatter to get Boolean output out of the box, because that's what we use that through layer as our login format to get a bunch of information. Plus, we have some additional metadata that we capture. Of course, as I said, is the application that pushes data to Elasticsearch, and it does that passing by AWS Kinesis stream. I didn't really want to write a sync that handled the pushing to kinesis. I thought that was a little bit too complicated to do and probably out of scope. So what I did, I looked around, found Vector. Vector can be deployed as a sidecar, is in the business area of data collecting, like Logstash or FluentD, if you're familiar with those. You just pipe the output from standard out into Vector, or you pipe the logs into a file, and Vector reads from the file, and then you can point Vector to log somewhere like AWS Virus. And they've done all the hard work on ensuring that everything is shipped, at least once guarantee, and so on and so forth. Plus, you can configure it to inject additional fields, which we do. So we inject, for example, the Kubernetes pod name, the Kubernetes IP, and a bunch of other stuff that comes from the environment, which I don't really want to encode into the application. So extremely nice. Also had some questions to ask, and the folks at Vector were extremely supportive to get the stuff done. Yeah, Vector is built in Rust. I think that's a good team for this meetup. Now, as I said, the same telemetry data, so the same traces that you collect by tracing, you can also use to get distributed tracing. Distributed tracing is very interesting when you want to observe how request hops through different services, which is key in a microservice architecture. The view is more or less similar to what you get in the Google Chrome developer tools, where you see all these like colored lines doing different things. And we use Jaeger for that. Unfortunately, I wasn't able to actually make it work because the tracing over telemetry is based on the Jaeger OpenTelemetry crate, which is using the blocking version of request to push traces if you're using the HTTP collector, which we do. And that causes an issue when you try to set it up at the beginning. If you're using Tokyo and setting up your own runtime, they don't like each other, and the tracing stuff blows up. So that we had to kind of pause. I'm currently working with the maintainers to implement a solution. There's a PR up which should solve the issue, and then eventually we're planning to work on a fully non-blocking solution. But you can also use spawn blocking, and that more or less does the job, depending on how much traffic you're handling. That's pretty much it. Donate Direct was a success, at least from the Rust proof of technology point of view. TrueLayer is investing in Rust going forward. In particular, we are starting a new greenfield project around core banking, creating current accounts, setting them up, managing ledgers, payouts, and loads of other cool stuff, starting entirely from scratch. I am the lead of this new project, and I'm currently on the lookout for 2 Rust backend developers, either currently experienced with Rust or very interested in learning the stack. Looking mostly on Milan, but if you have Rust experience, I'm really happy to talk, even if you're based in London or in the UK. And the opening has all the details you want in that link. But of course, if you have additional questions, I'm going to be around for the Matrix drinks afterwards. Plus, reach out to me either by email, Twitter, or find a way in the social media. Thanks a lot. I think it's QA time now.
Yes, thank you very much, Luca. As always, you really give us insightful, detailed talks. Loads of fire emojis, loads of clap emojis, loads of crab emojis, please, for Luca. Thank you very much. Now, I'm just going to share my screen again. I want to remind us all of a couple of things. So, for the question and answer session, could everyone please go into Slido and use this event code? We're now going to start taking questions to the panel of our speakers. You must use this event code and go to slido.com or sli.do. Those two URLs work. We're now going to start taking questions. So if you could just bear with me as I switch over. Amazing. Here we go. So can everyone see the questions up? Okay. Can everyone see the questions?
Yep.
Okay. Great. So we're going to start with the top question. And this is from
It's from me,
Luca.
guys.
It's from Luca. What is your
Yeah,
experience?
it's mine.
Okay, so it's from Luca to Sandro. To Sandro. So we're having an interpanel question. What is your experience at Smarkets with Cap'n Proto compared to gRPC, especially around crates and ecosystem support interests? So this is to Sandro from Smarkets.
Yeah. So for us, like I haven't worked with the gRPC, so I can't compare. Cap'n Proto was our framework of choice because we had already like our whole code base using in Python using Cap'n Proto. So we had our protocol, like our messages for communication between the components all defined in models in Cap'n Proto. So this was the reason we had to use because it was like the requirement for interoperability. Now, on the Cap'n Proto issue, it's reasonably smooth for Rust, but like I think it requires you to go a bit like verbose. For example, if you have in Cap'n Proto enum defined, the framework can generate for you this corresponding enum in code, but the structures you have to code them up from scratch. Like if you have a struct which has another substruct, you have to at least as far as we could see, we have to, if you have to serialize a message, you have to create this struct and then create each field in it, you have to set them in the code and then wrap them up in a message by hand. This is not nice compared to what we have in Python. I don't know if we have another way to do that cleverly. We tried to find, but couldn't see anything in Cap'n Proto as far as we could see. But yeah, we don't have many other options because this is what we have with all our ecosystem. We have to use Cap'n Proto. I don't know if this helps clarify.
Thank you. Thank you very much for answering that question. Next question is again to you, Sandro. Can you please share on what, if at all, is the question from Ibrahim to Sandro. Did the whole unsafe actics drama affect anything in the decision of continuing with Actics Web?
Not really, because we were considering, like we came across this I think this popped up a few months ago, and even I think the person who was in charge of the project was said that he was going to resign and all this stuff. But then since that the project has been adopted and then cleaned up a lot of this unsafe code that is there. I recently was looking into the code, and I mean, they have like still some uses of unsafe, but like just skimming over it, I don't see anything. I mean, I don't see anything impactful as far as I can see from other people using the framework in production. And there is now work that is trying to clean that up. So that put that assured, like the framework works quite well. We, as I said, we are not relying so much on the Actics web. We are more into the Actics, the core Actics, the actor model. And this is the one that we are looking into it, like to see how they use unsafe. It doesn't look like very impactful. I was looking to other Tokyo, for example, uses a lot safe as well in many points. I don't know how that can be, for example, a problem as well. This is the drama in terms of the ethics. I think was more about people than about technology. Like how, I mean, there is a concern, but the concern can be handled, and I don't see this as impediment for using the technology. If I help it to answer the question.
Yeah, thank you very much. And it often is an issue of people rather than the technology where it comes into play with certain things. The next question, I'm going to open it up to the whole panel. We'll start with Matthew on this one because I think this applies to everyone who's spoken. Can you please share on what, if at all, is missing in the Rust ecosystem for production use? So we'll start with Matthew, then we go to Luca, and we end with Sandro.
I have to say I'm probably not the best person to answer this, given, as I said, I haven't been personally doing that much Rust development. But speaking on behalf of the core team, for ages we held off on doing any stuff in production until async await finally landed. And I know that the Rumor project basically went on hiatus for about 3 years. From the initial development effort, and then said, right, we're just going to wait until this stuff is stabilized before we proceed. And then it continued once it landed. So now that is there, that really seems to have been the biggest sticking point. In terms of us using it in production, Seshat is our first instance of Matrix core team code shipping out in production, and it shipped in Riot Web or Riot Desktop 1.6 3 weeks ago. And I think it was quite a good stress test in some ways, because we're building it as native modules on all 3 desktop apps and plugging it in with the node wrap around the top. And whilst it's quite a constrained API surface, it's still got quite a lot of bells and whistles going on, and the multi-threading stuff of Tantavi. And other than the pain of getting the CI/CD to build the native desktop builds in place, which was admittedly several weeks, I think it might have been 5 or 6 weeks to get the entire build pipeline running. Once that was in place, we haven't had any disasters. So as far as I know, from our perspective, we have no reason not to just start pushing more and more stuff to production.
Thank you. Luca?
Well, I think the answer is really contextual, very much on what kind of production use we're talking about. I can answer for the production usage I've seen, which is mostly backend development. I think for backend development, Rust is a somewhat immature web framework story. So there's many options, but of course the API has been changing quite substantially since async await landed, which was an enormous shift in ergonomics. Like before async await, I wouldn't have said the Rust was viable as like a mainstream choice for backend development. Now, of course, when async await lands, that means that all the web frameworks which were built around the sync interface need to be able to offer the same ergonomics with an asynchronous interface. Web more or less LDAP. We're seeing new frameworks coming into play, but it's very much in flux. So the shelf life of what you build against today might not be as long as what you get in other ecosystems. Another point is the type of frameworks that are available. All the Rust frameworks currently available, I think Rocket might be somewhat the only exception, but up to an extent, are micro frameworks. Like to use a comparison with other ecosystems, they're very much like Flask in the Python ecosystem. We don't have a Django, we don't have a Laravel that can fulfill that niche. Now, for many applications, especially microservices, you don't need necessarily that kind of application, but they very much know that there's a need for it for other types of use cases, and other people might prefer that type of framework, and there's none at the moment in the Rust ecosystem. Third, once again, not there yet, is the sync story for databases. So there's a few new crate coming up, especially around SQL and Postgres, Tokyo Postgres and SQLX on top of Tokyo Postgres. But the ORM experience is a long way to go compared to what, for example, Diesel provides. But Diesel itself is still all asynchronous. And so you kind of need to spoon up the queries on a background thread, which, depending on your kind of performance profile, might or might not be optimal. So I think there's still a long way to go, and more than anything else, we're missing docs and just a community that is doing this thing. I was somewhat surprised when the Rust survey, when it came out, the Rust, most of the people filling the surveys were doing backend development, because we don't hear as much actually in like the mind share of the Rust ecosystem. And a lot of the material still doesn't cover that corner as much. So that's, once again, one of the things that is missing. Now, this is a blocker, but all of this makes it so that only an organization who's willing to put in some effort will adopt it. It's not an obvious choice. It still is today a bold choice for backend development.
Thank you. And Sandro, any insights?
I think pretty much what Luca said, like from us in our process, we came through, actually this was even part of my presentation, we came through this change in the technology that happened in a bit more than 1 year, and like many of the frameworks and the tools and the crates that we used became deprecated, and even the language evolved, and then some of the things that we'd done before we had to redo. And fortunately, the language evolved, and language and the crates around it evolved for better. But there is always this thing that the language is moving and changing, and like sometimes come across like some, if you are going to, for example, to try to integrate it with some other functionalities like stats-sd, that's one that we use for sending logs. We have to be careful, or Kafka integration, or maybe Sentry, that's what we use for operation to send the core dump if something happens in the code of production. Sometimes some of these libraries, they are not very well rounded up, or they are missing some features that you find, for example, in their equivalents for Python or so. So you have to be a bit careful, like how to really check properly which crates are going to use and how they have been evolved. So yeah, it's pretty much what has been said before.
Thank you very much for those answers. Now, next question is from one of our well-known prominent community members and community organizers, Giles Cope. Does Rust cap and proto play nicely with Python cap and proto? Did you get a chance to try interoperating? So how interop between Python cap and proto and Rust cap and proto works? That is to Luca, I think. Would that be to Luca? Or sorry, no, Sandro.
No. Yes.
Yeah, the cap and proto interoperation with Python is all the reason why we picked up this as our serialization format, and yeah, it works nicely with Python. It's pretty much what we have been doing all the time. So yeah, the only problems are the ones I said. It's quite verbose to implement on the Rust side, but once you have done it, you can exchange messages, and works quite well.
Thank you. Thank you very much for that answer, Sandro. Question for Matthew. Could we host this conference in Matrix, or is there more development required before video or audio is viable on the roadmap?
Well, we absolutely could host it in Matrix, and I think when we were doing the
let's make it happen.
Sound check the other week, I mean, we spoke about it, but we thought that the YouTube video stream and chat might be just easiest if that's what you used last time. But for instance, we do our own monthly meetup for Matrix called Open Tech Will Save Us. It's actually a general open tech kind of conference series, and we do the whole thing via Matrix. And to answer the question of voice and video, There are actually two flavors of voice and video in Matrix. You get one-to-one video calls using WebRTC, where we set them up using Matrix as if they were instant messages. And you get all of the end-to-end encryption and guarantees that you get with normal Matrix. However, that doesn't scale to conferences like you would use on, say, Jitsi, like we're using at the moment, because end-to-end encryption in Jitsi is very experimental and new, and also implementation-wise, nobody has yet hooked up a multi-conference unit or a stream forwarding unit for conferencing into Matrix for signaling. So what we do there is to use a different technology in Matrix called widgets, which are basically an iframe to allow you to put any arbitrary web content into a chat room. And we slightly special case Jitsi specifically so that you can just dunk Jitsi just like this one into a chat room, and everybody will be synchronized to go and view the same iframe. And it's actually really powerful in that you can build up dashboards, you can dunk in Grafana dashboards, you could put a YouTube widget in, a calendar widget, a Jitsi widget, etc., and basically build up all of the things which anybody in that room is at least given the option of seeing. So that's how we should be using it for sure. But instead, you'll just have to come down the pub into #rust-matrix.org, which is the link in the YouTube stream afterwards, for a deeply unsatisfying virtual beer.
Great. Thank you very much. Thank you very much. Now, another one of our regulars is asking the question to Luca. Hey, Ethan. How do the log crate macros work? Does it produce some kind of global state? And that is to Luca from Ethan.
Yeah. So I saw the question slide and I went to pick up the source code because I didn't know the answer, but I imagine it was the same. It seems it has a global static mute for the logger, and that it has a bit flag or an atomic counter that basically is used as a flag to say if the logger has been set or not. And you can only set the logger once. But the source code is very straightforward. So just go and pick.
Great. Thank you very much for the question. Now we have a contributor to Tantavi who is asking to Matthew. I think there was a question regarding Seshat.
Oh yeah,
there was a question on tracing that disappeared.
That might have been voted down, but Peter's still asking another question. Hey Peter, another one of the regulars, contributed to Tantavi, so it's great to have him in the room as well. What is the latency distribution for the order broker, and how do you measure profile it to prevent sudden jumps in response times? And I think that is to is that to Matthew?
No, it's to Sandro, I think.
The broker, I think,
That's to Sandro. Yes. Okay.
Well, to measure and to profile it, we have been looking into. We have two ways. Like we have the logs that we have been using to check the profiles, but we also have like the connect. We have the measure of the time that the messages are sent from one end to another. So the time that it goes to the exchange and goes back and comes back from the exchange, like we can measure this, and then this is the way that we have been doing our profiling. It's not really very nice. We have been trying to use Jaeger as well, so that we could introduce the way to send end-to-end measurements. I didn't take part into this in this step, but I think we had also some problems with when you are trying to integrate the library as well at the time. But in the end, we can observe this just from the other end, the end that sends the message, the pricing side that sends the message to us, and we get the response back, and you can measure the time for the response. So this is how we have been profiling. We get the pricing engine, that's the one that communicates with the broker. We have like this status SD that then we can measure the in Grafana or in graphite in Grafana the this answer, I think. Yeah, I think.
Okay. Cool. Thank you very much. I hope that answered the question. Peter has another question to Matthew. This is what he was asking about Seshat. What features are you most keen on from your indexing search engine? And that is from Peter to Matthew.
Yeah, great question. So first of all, Seshat was written by a guy called Demir, whose nick is Polya on Matrix and IRC, etc. So he actually did all of Seshat by himself as a one-man band. And it would be by far the best person to answer this. However, with my kind of Matrix general purpose hat on, the main things which I was looking for in terms of getting parity with Postgres full text search was stemming support, really important. Ideally, language, so locale-based stemming could be really, really useful so that we can actually index matrix rooms in a proper native language. We want to have Boolean operators so that we can do nice unions and differences, etc., on the results. And we also wanted time frame comparisons and searches in there so that you could say, hey, give me all the messages in the last 6 months, including the word synapse or whatever. So those are the kinds of typical search features. The other really more subtle feature that we've been playing with is the ability to gossip these indexes between clients. So we wanted the ability to be able to checkpoint the indexes on a customizable basis so that you could go and snapshot these and then know that you can incrementally sync those indexes over to your other clients and then keep indexing and keep kind of building up and have a customizable balance between the snapshot granularity and the, I guess, the size. So you deliberately compensate, have a compromise between how efficiently it indexed, but relative to how granularly you could synchronize between clients. So we went and have played with that a bit, and it looks like it works, which is super exciting. And I think it's the first time I've ever played with a full text search indexer that hasn't been deeply disappointing, whether that's Lucene or Zapier or something like that. And you think, oh, well, this looks like it'll be incredible. And then it's really disappointing. Also, super small footprint and also efficient indexes. We did have one disaster where we were checkpointing too rapidly and it started to leak RAM alarmingly. And it turns out that's just a design flaw. And if you try to checkpoint every 100 milliseconds, then it can get into a pathological state where it grows RAM caches faster than it can write them out. But that got fixed.
Cool. Thank you very much for that answer. Now we have the last two questions, one for Luca and then one from Luca. So the one for Luca is, would you recommend using the tracing crate over log in projects of all sizes, including cases where structured logging is not needed? So that's to Luca.
Okay, well, if you don't need structured logging, tracing crate does not add a lot. It also is fairly new. So the logging ecosystem has a lot of implementation that are very mature. So if you're not really interested in structured logging, most likely some fashion of Fern or mlogger will do what you need. So not necessarily. There was a question that disappeared about, do you need the logging crate when you have the tracing crate? No, you don't. So if you have the tracing crate, you can just use the event macros and just abandon the log crate entirely. And there is integration, so you still get the log events if you set the compatibility layer. So good story there.
Cool. Thank you very much for the answer. And the final question is from Luca to Sandro. And it is common feedback that Actix web documentation is a bit lacking. Has Smarkets tried to contribute docs? And if yes, how were the contributions received? And that is to Sandro.
Sorry, I was unmuted here. Yeah, it's a good question. Actually, we are really thinking seriously in contributing. We haven't done yet because we are still getting our head around in some other things in the more detailed ways to use some of these functionalities, especially not in the actics, in the actor model. And especially examples of like we have the documentation, but the documentation is not only lucky, but even if also it would be nice to have, for example, a way to say to showcase like how we use I don't know, wrap future instead of just saying, oh, wraps in a future into the actor. Okay, it's better to really have like some snippets of code documentation, and this is one thing that we are considering to do as soon as we get like we get finished the well, we get like a more mature stage in our development of our pricing engine.
Amazing. Thank you very much for that. Thank you to our panel of speakers for answering all of the questions and giving all of your insights. Thank you for all of your amazing talks. Thank you to all of the attendees who spent the time with us. I just want to give a last few announcements and shout outs. We're just going to switch screens. Right. So if you could please, again, follow us on Twitter at Rust London Users. Follow us on Twitter at Rust London Users. And we're off to the pub, our after meetup virtual pub, which is the Matrix Rust Room. The link should be in the description of the YouTube video. So check the description and join us in the pub for some virtual after meetup drinks. Some of the speakers will be in there for a while. You can continue the discourse. You can continue asking questions and continue connecting with each other. Again, Rust Dublin is on Wednesday. Rust Dublin are hosting their remote meetup on Wednesday. Oxidize, the Rust Embedded Conference, is open for speaker proposals. And I think, Luca, you said Rusty Talks, right, as well?
Yes.
So Rusty Talks is also open for proposals, speaker proposals, right?
Yes, they are.
Amazing.
So they're looking for 5 speakers, I think, looking in the CFP.
Amazing. Amazing. So if you want to give a talk at Oxidize, if you're into embedded stuff, Rusty Talks are also open for speakers as well. It doesn't matter about you not being in the geographical location, because I'm sure it's going to be a remote conference anyway. So why not? Why not give it a go? Again, thank you very much to Smarkets. Thank you very much to matrix.org. Thank you very much to TrueLayer. We'll see you next month in June for our Rust London virtual talks. Thank you all very much and have a great evening. Stay safe, stay well, look after yourselves. Take care, everyone. Bye.
Bye, guys.
Bye. Thanks.
Bye-bye.